Solution is that instead of resistive load inverters, use CMOS inverter. Okay, means we have just studied CMOS inverter as a single entity. We have not integrated that with any other circuit, yes or no? But whatever are advantages of CMOS inverter, those are applicable for higher level also. Means if I want to design SRAM circuit, I know that SRAM circuit uses 2 inverters, and if I use these inverters as a CMOS inverter, I can exploit those advantages of CMOS inverter in SRAM circuit also, yes or no? Because CMOS inverter, its static power dissipation is 0, means whether output is 0 or whether output is 1, there is no current from VDD to ground or VDD to VSS, so therefore power dissipation is 0, yes or no? Second thing is that its noise margins are very high, means why we are going for CMOS inverter, CMOS logic, because its noise margins are also very high. Why? Because high level output voltage is equal to VDD and low level output voltage is equal to 0. That is not case with any other logic. If you go with resistive load inverter, we do not get very high output voltage, or you will not get very low output voltage. That is the same case with NMOS inverter. We can replace this RD with NMOS inverter, means NMOS transistor also, that is in saturation mode or linear mode. But still there are some problems, and that is why CMOS inverter or CMOS logic is used. And therefore, we will study how to design static SRAM, that is CMOS static SRAM. CMOS SRAM. Now what I have to do? I have to draw 2 inverter circuits. This is PMOS transistor, this is VDD is applied here. Then I will use another inverter circuit. And there is back to back connection, means output of this inverter is connected to input of this inverter. Okay. Similarly, output of this inverter is connected to input of this inverter. Even though it is crossing, but there is no connection. Okay. Now I have to put 2 transistors that are called as access transistor. This is bit line, means information stored in this memory cell is transferred to this bit line during read access. Similarly, this side I have to add one more access transistor, and complement of memory bit is available here, so that is why I am calling it as bit bar. So this is 1 bit memory, means it is able to store, this memory cell can store just single bit of information. So this is bit line, it is having some capacitance, so that capacitance is called as bit line capacitance. Here is also some capacitance, that capacitance is called as bit line capacitance. Now for understanding purpose, I will give some numbers to this transistor. Suppose this is M1, this transistor is M2, this transistor is M3, this transistor is M4, this transistor is M5, this transistor is M6. Okay. These 2 access transistors are, gates of these 2 access transistors are connected together and given to access line. So these 2 transistors are used to read information stored in this cell or write some information in this cell, because RAM, static RAM means read write memory, means in this memory we can write something or we can read something. So how that operation takes place, I will explain with the help of this circuit. So first we will consider read operation. Read operation means something is stored in this memory and I want to read that. For example, consider here this is Q, internal node, and this is Q bar. This is internal node Q and this is internal node Q bar. Okay. Now just consider one is stored. One is stored here, logic 1 is stored. So definitely what will happen to Q bar? Q bar will be 0. Yes. So Q bar will be 0. Now what I have to do? I want to read logic 1, whether logic 1 is stored or not. Be it is means whether 1 is stored or not, and its complement is 0 here. Means I will do logic 1 read operation. So what is the procedure? Procedure is that this is called as bit line, this is called as bit bar line. Okay. This bit line and bit bar line are pre-charged to logic 1. Now what is meant by pre-charged to logic 1? Pre-charged means what? You know now what is meant by pre-charging. In case of dynamic logic, you have studied what is meant by pre-charging. Means charge on this capacitor will be logic 1. Charge on this capacitor will be logic 1. Means both capacitors are pre-charged to logic 1. That is, this capacitor is charged to VDD. This capacitor is also charged to VDD. Because that is the highest voltage available, or we consider logic 1 equal to VDD. So this is also VDD. So what I will do? I will explain this operation with the help of some diagram, with the help of some waveforms. Suppose beat and beat bar are pre-charged. So this is beat as well as beat bar, both are charged to logic 1, okay, during pre-charged. Now next thing is that what you want to know, whether logic 1 is stored or not. So you apply read pulse, because suppose you want to read something, what you have to do? You have to apply read pulse, yes or no? Read pulse is applied to access transistors M5 and M6. Means here I am applying read pulse. Pulse means what? You have to make high. This is read pulse, and this pulse is applied. This is suppose 0 and this is logic 1. This pulse is applied to gate of M5 and M6. Now tell me what happens. This pulse is applied to gate of M5 and M6. Now you can know the situation. This voltage is VDD, this voltage is VDD, this voltage is 1, this voltage is 0. Yes or no? And now at this instant I am applying read pulse. So what happens? M5 turns on and M6 also turns on. Why? Because this pulse, its highest voltage is VDD, which is greater than threshold voltage of M5 as well as M6. Yes. So therefore M5 also turns on, M6 also turns on. Then next what happens? Because logic 1 is stored here, and here also this node is pre-charged to logic 1, that is VDD. So therefore will there any current from this point to this point? No, because voltage at this point is also 1, voltage at this point is also logic 1, means VDD and VDD. So this transistor, even though this transistor is on, but there won't be any current. So therefore I can say that even if read pulse is applied, this beat line will remain at logic 1. Yes. But what happens to other side? That is beat bar. What happens to it? Voltage at this node is VDD, voltage at this node is logic 0, and read pulse is applied, means M6 turns on. So M6 turns on, then what happens? This terminal becomes drain, this terminal becomes source of M6, transistors enters into saturation region, yes or no? And therefore this capacitor, C bit capacitor, will discharge through M6 transistor, yes or no? So as this capacitor discharges through this M6 transistor, what will happen? Voltage of this beat bar line will start decreasing. Voltage of beat bar line will start decreasing, because this is pre-charged, it is not permanently connected to VDD. These lines are just pre-charged, means you can imagine like this capacitor and these capacitors are pre-charged to logic 1, yes or no. Once capacitor is charged to logic 1, when this transistor turns on due to application of read pulse, this capacitor starts discharging through this M6 and therefore voltage of this capacitor will decrease. This means that voltage of bead bar will decrease. At what point it start decreasing? When this read pulse is high. So what will happen? Bead bar voltage will decrease. So see, this is bead bar and this is bead. Then what happens? There is some difference. There is some difference between bead and bead bar line. This is VDD and voltage at this point is less than VDD. So this difference is applied to sense amplifier, means comparator basically. This difference is applied to sense amplifier, that is called as comparator. So what happens? At the input of comparator there is difference between these two lines, yes or no, and therefore output of comparator becomes 1. Output of comparator becomes 1, indicating that information stored in SRAM cell is logic 1. What it means? How to read contents of memory? Means decreasing bead bar indicates that information stored in memory cell is logic 1, yes or no? Got it? And this decrease in this is just of the order of millivolt, about 100 millivolt. Means if sense amplifier sense voltage difference between bead and bead bar line as 100 millivolt, then its output will switch either to logic 1 or logic 0 depending on what is stored in SRAM cell. Got it? Now in present case, as 1 is stored, although this transistor turns on but there is no current, so this voltage will not decrease. As here it is 0, complement of 1, this transistor turns on and this voltage will decrease, means bead bar voltage will decrease. That is indication of memory, logic 1 is stored in the memory. Now let us understand, when logic 0 is stored, what happens? When logic 0 is stored, means if logic 0 is stored here, what happens to this bit? Q bar becomes 1. Now what will happen in this case? Again procedure is same, bead bar and beat lines are pre-charged to logic 1. Means before application of this read pulse, voltage at this point will be VDD, voltage at this point will be VDD, yes. Now apply read pulse. So when read pulse is applied, now you know, you are very familiar that M5 and M6 turns on. But now in this case what happens? Voltage at this point is VDD, that is logic 1, voltage at this point is also VDD. So although this M6 is on, but no current will flow through this M6. So that's why voltage of this bead bar line will stick to VDD or logic 1. Now what happens when this is 1? Come to this point. This transistor turns on, voltage at this point is VDD, voltage at this point is 0 because 0 is stored in the memory. So that's why beat line will start discharging through M5. So as this line or as this capacitor start discharging through M5, voltage across beat line will decrease. So therefore this is now beat line. Earlier it was bead bar. Now what happens after the application of read pulse? If there is a decrease in voltage of beat line, what it means? It means that logic 0 is stored. If bead bar line decreases, then logic 1 is stored. Means in this way we can access information stored in memory cell, and that is the reason M5 and M6 are called as access transistors. Actually information is not stored in M5 and M6. M5 and M6 are just used to access the information. Means through M5 only we know what is stored in the memory cell. So this operation is called as read operation. Now similarly, what is important? How to write in memory cell, because this is read write memory. Only read operation is not important, but how to write in memory cell. Now for example, now we will see write operation. Now what do you think? Because you know read operation, how to read. So can you think something how to write in this memory cell? Writing in memory cell means what? Modifying the contents of memory. Yes or no? Writing something in memory cell means modifying the contents of memory. Suppose in this cell 0 is stored here and 1 is stored here. Means 0 is stored. Now I want to change it to logic 1. I want to write 1 in this memory cell. Then what is the procedure? Procedure is, if you want to write 1, then forcefully connect this bit bar line to logic 0. There is another circuitry or special circuitry that is called as read-write circuitry. Okay. There is read-write circuitry. Then write circuitry, what it will do? Suppose you want to write 1 in memory cell, then write circuitry will forcefully connect this bit bar line to logic 0. Got it? Forget about this line. We don't have to bother about this bit line. But if you want to write logic 1, what you have to bother? You have to bother about bit bar line, and you have to connect forcefully this line to logic 0, and that is automatically done with the help of a write circuitry. Now imagine logic 0 is connected here, means this line is forcefully connected to 0. What happens? If this line is connected to 0, this is first step. Next step is apply write pulse. Again write pulse is applied to gate of M5 and gate of M6, that are access transistors. Now let us imagine this situation. Logic 0 is stored in the memory, that is Q, and Q bar is 1. This is Q bar, this is Q, means up to this point. We will see only after this. 0 is stored, so Q bar is 1. So what I want to do? I want to write 1. So what you have to do? This bit bar line, suppose that bit bar line is earlier 1, then suppose you want to modify the contents, then bit bar line is changed to logic 0. It changed to logic 0. And then what you have to do? Then you have to apply read pulse, write pulse. This is write signal, and write signal you have to make it high. Just understand operation in this way. Suppose this is t equal to 0, and this is situation before t equal to 0. So at t